Welcome to MRU E-Learning powered by Malla Reddy University. This is V. Anil Santosh, working as an assistant professor in the Department of Cybersecurity. Today I want to present on strategies for algorithm design and analysis. Okay. In this session, I want to discuss regarding about what is an algorithm, what are the properties in algorithm, how algorithm can be designed based on how this algorithm performance can be calculated. These are all the things we are going to be discussed in this session. Okay. Step-by-step process for solving a particular task or a problem is known as an algorithm. See, whatever the problem statement you are going to take for that particular problem statement, how the solution can be provided. Okay, this algorithm will clearly explain about based on the problem statement, the solution can be provided in the form of a steps. How the problem to be solved. How this problem to be solved, on what basis the task is going to be performed, based on how the input is going to be taken, based on the input, how this algorithm process has been completed, based on that one, how the output is going to be generated. Whether after getting the output, whether the result may be correct or if you are facing any errors. These are the things we are going to be thinking. Okay, now what are the characteristics of an algorithm? Okay, the characteristics of an algorithm will be input, output, definiteness, finiteness, as well as effectiveness. Input is nothing but what type of data has to be determined. Okay, for algorithm, we need to pass at least 0 or more well-defined inputs. Based on the input passed, we are expecting at least one output or more than one. At least one output or more than one, it has to be produced. Okay. Next is definiteness, means once the algorithm process has been started, approximately how much amount of time it is going to take, it should be. Always we need to give the instructions to the algorithm should be very clear. It should not be unambiguous. Because once we are giving the instructions to the algorithm in a clear manner, then the algorithm process has to be executed. Then only we can able to expect the better result. The finiteness means approximately once the algorithm process has been started, within the finite amount of steps, approximately how many number of steps the process has to be completed, it should be terminated. Say for example, the execution of algorithm will take 15 minutes. It will take around 15 steps to execute. Within the 15 steps, if the algorithm process has been executed, approximate time we are going to take for executing, that is 15 minutes. Within the 15 minutes, the algorithm process has been completed. That means that will be considered as a best case time complexity. And the next category of the time complexity will be worst case time complexity. This will clearly explain about the worst case means, okay, within the given expected timeline, if the algorithm process not yet terminated, still the process is going to be running state, that will be treating as a worst case time complexity. These are the things we are going to be learn in detail in the upcoming slides. The next one is going to be effectiveness. What is called as a effectiveness means whatever the instructions to the algorithm we are going to be passed, that should be simple. These all the things are going to be executed within the finite amount of time. That is stipulated time, it is going to be done. Okay. Okay, these are the properties or characteristics or features of an algorithm. Now, the basic thing we are going to be how the algorithm design has to be done, what are the various steps are required for a designing of an algorithm. See, the basic steps is, the first one will be the very important one, what type of problem statement we are going to be take. After taking the problem statement, how this problem statement is going to be analyzed, how the decision making can be done, what are the parameters required for making the decision, and what are the specification required, how this algorithm verification has to be done, how the analysis of an algorithm can be done, how this implementation can be done. These are the very, very important steps for designing of an algorithm. Okay, first we are going to see understand the problem. What is called as understand the problem? See, whatever the problem statement we are going to take, once we are aware of the problem statement, we need to understand the complete problem description, For that problem, we need to understand the description. For that solving of that particular problem, what are the inputs required for solving that problem? Once we are going to, this is going to be called. Next is decision making. Decision making means once the description we are completely aware of that, what type of inputs required for solving that problem statement. Either we require any computational devices or not, whatever the data structure algorithm is going to be required for solving that particular problem. Okay, based on this one only, the decision making can be done. In general, we are all aware of that pseudocode is for expressing the algorithms. Here, whatever the specification of algorithm is we are going to be take, it is very simple to specify an algorithm by using natural language. For expressing of an algorithm, pseudocode is compared to easier. Okay, now we are going to see a simple example how an algorithm is going to be done. Okay, what is example I'm going to take here is write an algorithm to perform addition of two numbers. For solving addition of two numbers, see, this is example have been taken. See, first of all, I should know if any problem statement I'm going to take, I don't know how to solve. Just I don't know how to prepare the logic and everything. At that time, the first thing will be, we need to develop the algorithm. Once the algorithm, development of algorithm can be done in the form of a steps. This form of the steps, next we are moving to flowchart. These all the steps we are going to be written in the form of a flowchart. The flowchart, you are already aware, the flowchart is nothing but pictorial representation. The symbolic representation of all these steps should be written. And next one, then after we can able to develop a program by selecting of our programming language. Here, the algorithm I have been taken is read the first number, say A. For implementation of addition of two numbers, how many number of variables are required? I required three variables, namely A, B and C. First of all, I'm going to pass a values for A and B, that all the values has to be read, then the addition operation is going to be performed, then we are going to display the result. Read the first number, say A, read the second number, say B, add the two numbers and store the result in a variable. And finally, in the last step, we are going to display the result. Is it clear? This is algorithm. Here, algorithm is the keyword. Sum is nothing but name of the algorithm. And A comma B will be called as a parameters. Okay. This is a logic I have been prepared. C equal to A plus B. That is C tends to A plus B. The complete result is going to be stored in the variable C. We are going to display the value C. C. Okay, whatever the value of C consisting of, that is going to be displayed. Okay, now after giving the input, the processing has been completed. We are producing an output. Whether we need to check whether the algorithm gives the given correct output within the given finite amount of time or not, that we need to check. Okay, within the finite amount of time, the algorithm process and the correct output is going to be displayed. As usual, that will be comes under the best case, as well as within the finite amount of time, the algorithm process should not be completed. Still, the algorithm is running. That will be treating as a worst case time complexity. That we are going to be learn in detail. Analysis of an algorithm. How this algorithm can be analyzed. What are the parameters required? Here, the parameters are going to be required is, first one is time efficiency, that is space efficiency, how the simplicity of an algorithm, instructions, and what type of input we are going to be produced. These are the things it is required for analyzing of an algorithm. See, what are the reasons why algorithm has been completed within the finite amount, or it will take a minimum late, the running late. These are the things we are going to be discussed. Okay, now we are going to see what is simplicity. Generating sequence of instructions. How the sequence of instructions are going to be generated. Once the generate, which are easy to understand. See, already in the earlier slide, we have been seen whatever the instructions we are going to pass for an algorithm, that all the instructions should be very simple. It should not be ambiguous. Okay, it should not be confused to the algorithm. Should be very clear. That means Generality shows it becomes easier to design of an algorithm. The generality will clearly explains how the design can be able to make the design to be easier. What type of inputs we are going to take. Based on the problem statement, we are going to take the certain number of inputs for designing. It will be helpful. And finally, the very important step of this part is going to be analysis of an algorithm. See, these all the things will be comes under the part space complexity, time complexity, simplicity, generality, and the range of input. Okay, how this algorithm can be implemented. For example, implementation of algorithm can be done. So for example, if you are supposed to take the object-oriented programming concepts for implementation of this algorithm, it is better recommended to use the programming languages. This can be developed with the help of programming languages like object-oriented programming like C++, Java, Python, and etc. Okay, writing a program for the given algorithm, it is essential to write an optimized code. This will reduce the burden on the compiler. Optimized code means the functionality, say for example, a program can be written in 10 lines without removing any functionality. If any developer has to write the code within 6 to 7 lines, at least 3 lines, it will be less burden to the compiler. This process, in this way, the code can be optimized. Okay, the next we are moving to very important topic, that is performance analysis. How the algorithm performance can be calculated, on what basis, what are the things are going to be required. The efficiency of an algorithm can be decided by measuring the performance of an algorithm. Approximately how much amount of time taken by an algorithm to execute, amount of space required to run an algorithm. This is popularly known as time complexity as well as a space complexity. Based on these two factors, where we can able to analyze time performance of an algorithm by using these two factors. Okay, analysis of algorithm can be measured by measuring input size, measuring space complexity, measuring time complexity, measuring running time, as well as order of growth, as well as best case, worst case, average case based on the computing. See, space complexity. If an algorithm want to run means, definitely we require a space complexity. The amount of space required to run an algorithm. For example, for computing the space complexity, we require the major things, that is constant as well as an instant. The space requirement can be defined by the equation S of P equal to C plus SP. Here where the C is nothing but is called as a constant, that is nothing but it is a fixed part, it cannot be changed. SP is nothing but space dependent upon the instant characteristics. SP is nothing but space dependent upon the instant characteristics. Okay, that will be. Okay, once the program has been stored, means the next part is going to be the time complexity. It is one of the major factor. The time complexity of an algorithm is the amount of computer time. Required to run an algorithm for completion of the process. Computer time, not as a physically clocked time. Always physically clocked time is not recommended. That is the reason we are going to take always computer time only to run an algorithm. For example, for instance, in multi-user system, executing time depends upon the many factors such as, that means, say for example, I'm going to take the two computers, namely A and B. Computer A is having a high configuration. Computer B is having a low configuration. At that time, I want to run one algorithm in both of the systems parallelly in two different systems. Definitely, A computer is having a high configuration. B computer is having a low configuration. The process will be completed within the finite amount of time in the A but not B, because A contains the highest configuration. That is the reason. Load also will place a very major role. These are the factors that are going to be influenced. System load as well as number of other programs running. If all the programs are running state, automatically it will take more amount of time to complete the process. That is the reason recommended is to always we need to reduce the system load. Number of programs running is also will be less. What type of instruction set we are going to be used depends upon the hardware also will plays a very major role. Here, the time complexity is therefore given in terms of frequency count. What is called as a frequency count? Frequency count is nothing but denoting number of lines of time, number of lines has been executed. Approximately each and every line will take how much amount of time. Each and every statement has to be executed how many number of time. For algorithm running, this will be going to be called as a frequency count. This is going to be seen with an example in the next slide. Okay. Example, if the input size is longer, then usually algorithm runs for a longer time. If the input size is longer, that will be the average case. If the input will increases, automatically the running time of an algorithm will increases. Okay, we can compute the efficiency of an algorithm to which input is going to be passed as a parameter. This is we are going to be learned with an example. I'm going to take the matrix addition as well as a multiplication or anything we can take as an example. Say for example, order we are going to take. Either we are going to take the 3 cross 3 or 6 cross 6 based on the size, how many number of elements are going to be entered into the matrix, the time will takes in that part. Measuring running time. The time is measured in terms of called as a frequency count. We need to identify what is the core logic of the program that is going to be calculated here. Core logic. For example, inner loops running more amount of time compared to the outer. That means example sorting. Generally, the basic operation is located in the inner loop. Example in our daily life example, that is sorting of elements. The sorting of elements is nothing but once we are taking the example in the form in the array, the order will be 10. All the 10 elements will be in the form, the combination of ascending plus descending order. Whatever the sorting technique you are going to take, our target is to, the element has to be arranged in the form of ascending to descending order. While comparing with the first element with the second element, because it depends on this one, several number of comparisons will require. If the array size will increases, automatically the comparison time will be also increases. See, this is an example. We are going to take one algorithm, how the frequency count is going to be calculated. The frequency count is going to be calculated. How many? We have been written 7 lines of this one. For example, this is algorithm is the keyword. Sum is nothing but name of the algorithm. A comma n will be called as a parameters. Okay. While running this part, this will execute 0 lines. For example, here the loop will be for I equal to 1 to n, depends upon the size of the n passed by the user. The algorithm running will takes that much amount of time. Say for example, the value of n will be depends on the user. This line will reads n plus 1 times. This line will reads n plus 1 times. The next is s equal to s plus a of I. Index position, that is this line will reads n times, and finally we are going to return the value of n. And finally, after adding these all the things, the frequency count will be called as a 2n plus 3. This algorithm will runs 2n plus n3 times. Based on individual line we are going to be calculated. Okay. Based on these two factors, we are going to calculate the performance of an algorithm. Majorly computing order of growth, time complexity, space complexity, best case, worst case, average case, measuring the input size. These all the parameters are going to be required. Okay, based on this one only, we can able to analyze how the performance of an algorithm has been calculated. Now the next topic we are moving to is asymptotic notations. This asymptotic notations will clearly explain about which algorithm we need to choose. This will be clearly explained by asymptotic notations. To choose the best algorithm, we need to check the efficiency of each algorithm by how the things can be measured. This one we can measure by computing time complexity of each algorithm. In the already earlier slide we have been saying, always we are going to calculate the computing time but not the physical time. In these asymptotic notations, we need to check the efficiency of each algorithm. Based on the time complexity, we can able to analyze which algorithm has completed the fastest, which algorithm has completed the slowest, which algorithm will be based on the input, how the average time will be done. Fastest and slowest and the average time. With the help of these asymptotic notations, it is a shorthand way to represent the time complexity. The various notations we need to represent the asymptotic notation, that is big O notation, omega notation, theta, little o, little omega. These are the different type of notations where we can able to see. Among this one, the very first important notation will be big O notation. It is represented by the big O. With the help of this notation, always we are going to represent the upper bound of an algorithm running time. That is, longest amount of time it is going to be calculated. Longest amount of time. For implementation of big O notations, we are going to take the two functions, namely f of n as well as a g of n. Say for example here, f of n equal to 2n plus 5 as well as g of n equal to n square. Okay, we are going to substitute the value n equal to 1. Initially, after analyzing n comma 1 comma 2, at whatever the value of g of n will be increases, automatically that we are going to be considered this one based on this functions, namely. Always we need to take the positive functions only for implementation of big O notation or omega or whatever it may be. These notations. Okay, see, this is a graph. Initially the g of n value, f of n value will be served as a lower boundary as well as g of n will be served as a upper boundary. Initially f of n will increases, after that one g of n will be increases as per the earlier example at value of n equal to 3. Okay, this one. The equation is going to be always f of n value should be greater than or equal to c star of g of n. Here what is c is going to be called as a constant. Okay, and finally big O notation will clearly represents the longest amount of time. It is going to be calculate the longest amount of running time of an algorithm. Okay, the next notation is going to be omega notation. It is quite opposite to big O notation. In this omega notation, representation by using the symbol is omega. It is going to calculate the lower boundary of an algorithm running time. It is going to be represents the lower boundary of algorithm running time. We can denote the shortest amount of time taken by an algorithm. Shortest amount of time. For implementation of this also, we are going to take f of n and g of n are the two functions. Always compared to the g of n value, always the f of n value should be higher. Here as usual c will be called a constant. Here the f of n will serve as a upper boundary and g of n will be served as a lower boundary. Next, this is a simple way to represent omega notation. Initially, g of n value will be increases. After that one, f of n value will be increases. Wherever the f of n value increases at that point, say for example, n value equal to 2, the f of n value increases. Okay, this value is going to be considered. That will be treating as your n naught. Okay. This is an example have been taken. F of n equal to 3n plus 2. G of n value will be. This is a symbol. F of n equal to omega of g of n. We are inserting the value either n equal to 1, 2, 3 or whatever it may be. At any point of time the n value depends the graph we are going to be draw. And the third notation is going to be theta notation. It is represented by the symbol theta. In this notation, the running time between upper boundary and lower boundary. It is going to calculate the running time between the upper boundary as well as a lower boundary. Big O notation will represents the upper boundary. Omega notation will represents the lower boundary. In between the lower boundary and upper boundary, theta notation is going to calculate the running time between the upper as well as a lower. For implementation of these two things, again we are going to take namely two functions as well as f of n as well as a g of n. These two constant namely c1 and c2. C1 value is always less than or equal to f of n value is less than or equal to g of n. Okay, f of n equal to theta of g of n. This is a graph representation. This will serve as an upper part. This will serve as a lower bound. This f of n part will be treating as a running time. This will be treating as running time. This part we required in between upper as well as a lower. And last notation is little o notation. It is represented by the symbol omega. Limit n tends to infinity, f of n by g of n equal to 0. And little omega equal to limit n tends to infinity, g of n by f of n equal to 0. Thank you.